Day 246 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 246, and today we have question number 130, surrounded regions. The difficulty level is medium, but you already know if you've been to this channel before that we're going to keep the solution as simple and easy to understand as possible, so let's get into it. Question says, you are given an n by n matrix board containing letters X and O. Capture regions that are surrounded. Connect a cell is connected to adjacent cells horizontally or vertically. A region. To form a region, connect every O cell. Surround. The region is surrounded with X cells if you can connect the region with X cells and none of the region cells are on the edge of the board. To capture a surrounded region, replace all zeros with X and it's in place within the original board. You do not need to return anything. Okay, y'all, so let's break that down by looking at example 1 so we can see what it is that they're talking about. First thing we need to do is let's go over this input and output so we can see how this input and this output correlate to these n by n matrix grids that they gave us, right? So if you just each one of these arrays represent a row, right? So in the input, this array will give us this row. Then this array will give us the second row. This array will give us the third row, and so on, so on. So let me just do it like this so y'all can get a visual representation of it, right? So we put this there, that'd be the first row. And we put this here, boom, bada boom, bada bing, that'd be the second row. Put this here, bada boom, bada bang. That's the third row. And then finally we put the last row at the bottom, and that would be like so. So if you look at this, you'll see that this right here that we just created, this is the exact same thing as this n by n matrix that they give us in the explanation. In the example, it's just how it's formatted. It goes like this, right? It's in a 2D array with arrays of rows inside each inside of the initial array, and that's what makes it a grid. So that's the input. Let me go ahead and do the same thing for the output so I can show y'all how it was mutated or excuse me, how it was changed in place so that they got the output, the desired output, right? So that's boom, boom, boom. Let's see. So this is the output grid that I'm putting over here, right? So I could just show y'all what happened, right? So first thing we need to do is we are trying to capture the region. So we need to know what a region is. So excuse me, y'all, to form a region, right, we need to connect every O cell, and to connect, it has to be a cell is connected connected to adjacent cells horizontally and vertically, right? So it can't, diagonal doesn't count. So this right here, this is its own region, and then these three O's right here is its own region. So we're starting this O, these two O's, and this O, that's all the same region. But this O doesn't count, or this O is its own region because it's diagonal. So we don't count it in the same region as this because diagonal doesn't count in the form when we're dealing with the connect. We can't connect diagonally. We can only connect horizontally and vertically. So that's why right now there are two different regions, right? So then it says surround. The region is surrounded with X's if you can connect the region with X's cells, X cells, and none of the region cells are on the edge of the board, right? Then it says to capture a surrounded region, replace all zeros with or all O's with X's in place within the original board. So what we're doing is all surround this region is surrounded, right? Because there's an X right here, there's an X right here, 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 X right here. Those are all surrounded. They're all vertical and horizontally. It's surrounded. And since it's surrounded, that means we can capture it. And that's why when we capture it, this board will look like the input will look like the output. I'm gonna just show you on the input board so you can see. But when we capture it, we're turning all the zeros into X's in the surrounded region, right? But it says you do not. It says you do not need to return. Oh, right here it says the cells are not, and none of the region cells are on the edge of the board. So since this O, or this O right here, which is this O right here, since it's on the edge of the board, we cannot capture it, right? So we have to leave that as is. However, all the other O's, as you can see, we have captured. They were right here. All these O's we just turned into X's. When you look at the output, we turned all those O's into X's except for this O, because this O is on the end of the board. And we did that because it was surrounded. So it was surrounded by X's, so that means we can capture it. So boom, that's how we got this input and turned it into this output with these two pictures right here to help us understand. And the explanation says, in the above diagram, the bottom region is not captured because it is on the edge of the board and cannot be surrounded. Now, let's look at example 2. If they try to throw some tricks our way, in example 2, we would just have 1x and the output will be 1x because there are no O's that we need to capture, right? There are no regions to capture, so we can just leave it how it is with the all X's, with just the straight X. So now that we understand what the question is asking, y'all, let's get into the fun part, the actual solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, don't forget to like, comment, and subscribe, y'all. It is appreciated. Now let's get into it. So the first thing we need to do is we need to understand how we are going to do this. And how we are going to do this is we are going to use a depth first search. So the first thing we need to do is we need to create our helper function that's going to perform the depth first search for us, which will mark the connected O regions, right? So we need to be able to find a way to mark the O's that are connected like this, right, in each region, so we can form each region. So in order, we're going to do a depth first search to do that. So first thing we're going to do, we're going to say help. We're going to create a helper function. So come outside this main function right here. We're going to create a helper function. We'll call it DFS. Open up the parentheses, underscore. It's going to have a board, colon. That's going to be a 2D array of characters. Boom, just like that. Come outside that 2D array, put comma. Then we're going to put underscore row, colon. That's going to be an integer. Then we're going to put underscore col, which is short for column. Then we're going to put colon. That's going to be integer as well. Then we're going to put another underscore, and this is going to be called new board, colon, and this is going to be in out, which is going to let us change things in place, which is what they want us to do. It says somewhere up here that we need to do, oh, right here, in place within the original board. So this in out is going to let us, this in out parameter is going to let us do what we need to do in place. Then we're going to say open up two square brackets. It's going to be another 2D array of character, just like so. Now it's time to open up the brackets and let's get started on the function, y'all. So first thing we need to do is we need to ensure the current cell is within the bounds and is an O that hasn't been marked yet, right? So remember, in the bounds means it's not on the edge, right? So first, in order to do that, we just need to say guard, open up, don't open up the brackets. We're going to say guard row is greater than or equal to 0, and that's going to check if the row index is within the bounds, right? So that's going to handle the row index. Now let's do the same thing for call. We're going to say, call is greater than or equal to 0, and that's going to make sure the column index is within the bounds. Now we need to, we're not done yet. Now we need to say row is less than board.count, comma, and that's going to check if the row index is less than the total amount of rows. Then we need to check to see if the column index is less than the total amount of columns. So in order to do that, we're going to say call is less than board, open up the square brackets 0 dot count. Then we need to say comma. Then we need to ensure that the cell hasn't been marked already in the new board. So in order to do that, we just say new board, open up the square brackets, square brackets, row, come outside the square brackets, open up more square brackets, call, and we're going to say equals X. Boom. Then, comma. Then we need to check if the original board cell is a 0, right? So in order to do that, we're just going to say board, open up the square brackets, row, come outside of that, open up the square brackets, call. Then we're going to say equal, open up the quotation marks, O, just like so. Then we could come underneath all of that and we can say else, because remember it's a guard statement, so we're going to say else, open up the brackets, we can just return. Now we need to mark the current cell as O in the new board, right? So in order to do that, we're just going to say new board, open up the square brackets, row, come outside those square brackets, open up more square brackets, call, come outside those square brackets, equals, open up the quotation marks, and put an O inside of that. Now we need to recursively explore all 4 neighboring cells, meaning we need to check the up cell, the cell above, the cell below, the cell to the left, and the cell to the right. So in order to do that, we're going to do that recursively by saying DFS, open up the parentheses, board, comma, row, plus 1, comma, call, comma, and new board. So what that is going to do is it's going to check the cells beneath us, right? Now we need to check the cells above us. In order to do that, we're going to say DFS, open up the parentheses, board, comma, row, minus 1, comma, call, comma, and new board. Boom. Now we need to check the cells to the left of us. To do that, we're going to say DFS, open up the parentheses, board, comma, row, comma, call, minus 1, comma, and new board. And now we need to finally check the cells to the right of us. And in order to do that, we're going to say DFS, open up the parentheses, board, comma, row, comma, call, plus 1, comma, and new board, just like that. Now, that should be it for the helper function, y'all. That should be it for the helper function. Get one more look at it. Now let's get into the main function, right? Main function, what we need to do, let's see how I want to do this, right? Well, first thing we need to do is create a new board, initialize the X for every position, right? So we're just going to create a new board and we're going to mark everything with X just to start. So in order to do that, we're going to create a variable. We're going to call that new board, colon. It's going to be a 2D array of characters. So open up 2 square brackets and put character in the middle of those. That's going to be equal to an array. Remember, it's a 2D array. So the first array is just, we're going to say equals array, open up parentheses, and we are going to say repeating colon. And since it's a 2D array, it's going to be repeating more arrays, right? So it's going to be repeating array. Then we're going to open up the parentheses again. We're going to say this time that array is going to be repeating, open up the colon, open up the quotation marks. It's going to be repeating X. Come outside of that, we're going to say comma, and the count is going to be count colon board square bracket 0 dot count. Come outside of those parentheses, because that's just the array inside of the arrays, and then we're going to say comma, and now we need to do the count for the initial array, and we're going to say count colon board dot count, whatever that may be. Now it's time to iterate over the edges of the board, the first and last row and the first and last column, because we need to see if there are if there are any O's on the edges of the board. So in order to do that, we're going to come down here. We're going to say for row in board dot indices, open up the brackets. We're going to say for call in board, open up the square brackets, row dot indices, excuse me y'all with my spelling, where, open up the parentheses, call equals equal sign 0. Then we're going to say or call equals board square brackets row dot count -1. Right? Then we're going to do the same thing for the row. So we'll say or row equals 0, not comma, or row equals board dot count -1. Then we come outside of those parentheses, open up the brackets, and we are going to perform this depth first search on the edge of the O cells and mark the connected regions on the new board. So this is where we're going to call this helper function that we just created, and we're going to say DFS, open up the parentheses, board, comma, row, comma, col, comma, and new board. Boom. Remember, this and sign goes together with this in out parameter. So anytime we use this in out parameter, we got to use this and sign. Then we're going to come down here, or I believe anytime, I don't know, might got to check me on that, but I believe anytime we use in out, we have to use that and sign. Then we're just going to come down here after marking the edge connected O's. After marking the edge connected O regions, now we need to update the input board with the new board. So in order to do that, we're just going to say board equals new board. Just like so. So let's run it, see how it runs. Hopefully we get that first try. Ooh, first try. That's what I'm talking about, y'all. Let's submit it. Make sure it stays accepted after we submit it. See what that time looking like. Ooh, the time, we can get the time better. 4 milliseconds, 38.64 beats 38.64% of users with Swift, y'all. Don't worry, we'll get those times up as we go further down our LeetCode journey. We're just trying to have a solution to the problem that's presented to us. And right now, I feel like this is a good solution. I know parts of it gets a little long. Like these parts might seem a little long, but get one more look at it before we leave. Get one more look. This is the helper function. Get one more look at this helper function. One more look at it. One more look at it. And then get one more look at this main function, y'all. And yeah, that's all for today. I hope y'all learned something, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.